An attacker does not need to open the box today. They can steal the sealed box now, store it, and wait for a better key. That is the basic fear behind post-quantum cryptography. Not that quantum computers are breaking your bank login this afternoon. They are not. The problem is the data that needs to stay secret for a long time. Medical records, financial data, government secrets, private messages, anything where we will decrypt this in 10 years is still bad. Right now, a lot of digital trust depends on public key cryptography. That includes familiar building blocks like RSA and elliptic-curve cryptography. These systems help websites prove who they are, help systems agree on secret keys, and help signatures say, this came from the right place. But a sufficiently powerful quantum computer could threaten some of those public key systems. That phrase matters. Sufficiently powerful. We do not know the exact year. We should not pretend there is a countdown clock floating above the internet. NIST says estimates range from a few years to a few decades, but defenders have an annoying scheduling problem. Attackers do not have to wait until the quantum computer exists. They can collect encrypted traffic today and save it for later. This is called harvest now, decrypt later. It is exactly as cheerful as it sounds. Imagine attackers stacking locked boxes in a warehouse and labeling them, open when future math arrives. Post-quantum cryptography is the plan for changing the locks before that future key shows up. And no, this is not quantum magic. Post-quantum cryptography is not the same thing as quantum cryptography. It is ordinary software using algorithms designed to resist both classical and quantum attacks. The important word is designed. Do not hear quantum-proof forever. Hear built for the known quantum threat model, analyzed and intended to replace the parts we know are at risk. In 2024, NIST finalized its first 3 post-quantum cryptography standards. For this episode, you only need the short version. ML-KEM is for key establishment, helping systems agree on secrets. ML-DSA and SLH-DSA are for digital signatures, helping systems prove that messages, software, or certificates are authentic. That is already more acronym soup than anyone should drink before lunch. So here's the mental model. Key establishment is the lock on the conversation. Digital signatures are the stamp that says, this came from the real sender. Post-quantum migration means replacing both kinds of old public key machinery without breaking the systems that rely on them. And that is where this becomes less sci-fi and more asset inventory with a mild headache. A defender cannot just say, install PQC and call it done. They need to know where public key cryptography is hiding. TLS connections, certificates, domains, servers, APIs, software updates. Vendor products, old appliances everyone is afraid to reboot. Some post-quantum material can be larger. Old devices may not handle new handshakes cleanly. Certificate plans may change. Vendors need roadmaps. Testing matters. This is why crypto agility matters. Crypto agility means your systems can swap cryptographic parts without rebuilding the entire house around the doorknob. There is also a policy reason this is no longer an abstract research topic. On June 22, 2026, the White House issued Executive Order 14412, which sets U.S. federal migration milestones for high-value assets and high-impact systems. For that covered federal scope, key establishment has a 2030 deadline, and digital signatures have a 2031 deadline. That does not mean every private company on Earth has the same mandate, but it does mean the direction of travel is clear. Federal systems, contractors, vendors, and security teams are being pushed toward real migration plans. So here's the defender version. First, find your cryptography, not just the one certificate everyone remembers. Find the key exchanges, signatures, PKI dependencies, vendor boxes, and systems protecting data that must stay secret for years. Second, prioritize long-lived data. If stolen encrypted data would still hurt in the future, it belongs near the front of the line. Third, ask vendors boring questions early. Which algorithms will you support? When? How do we test? What breaks? What gets bigger? What needs a firmware update? Boring questions are cheaper before the deadline is on fire. The misconception to avoid is simple. Quantum computers did not already break all encryption. The real story is more practical, and honestly more irritating. Some of our most important public key locks may not be good enough for the future. The standards for new locks are arriving. The migration takes years, and the attackers can start collecting boxes before anyone finds the replacement keys. That is post-quantum cryptography. Not panic, not magic. Just a very large lock replacement project that defenders should start before the warehouse fills up.